All right, so today we're going to be looking at our intro unit, notes number 9, and we're going to be looking at quadratic characteristics from an equation. So our goal today is that I will be able to identify characteristics. I should say characteristics, but that's really messy. Of a parabola from an equation. That's going to be our goal today. So instead of giving you the graph, I will give you an equation and we're going to identify some pieces. So the first thing we need to know is that you can always sketch a graph to reference. So draw a sketch. Okay, use the calculator, draw a sketch of the graph for reference. Okay, so if ever you're like, I don't actually really know what that looks like, then you can put it in your calculator and sketch it. Okay, so the first thing we need to know is that there are 3 different forms of quadratic functions, 3 different types. The first one is standard form, so no parentheses. Okay, so this could, for example, the one that we've seen a few times is like y equals 1/2 x squared minus 2. I think that was a question from our notes yesterday. Okay, so that's one that you might have seen. That's an example, standard form. Vertex form, we've also used a lot. So example of this would be y equals -2 x plus 1 squared, like minus 3. I think that might have been in our notes from yesterday. Okay, so that was one that we've seen before. We haven't done anything with intercept form, but we will be doing a lot with intercept form actually in our next unit, unit 6. Okay, so we haven't actually done with anything with it yet, but we will get there. So we can find the vertex from these 2 forms. Okay, it's actually pretty straightforward. So far we've put those in the calculator and looked at the table to find the vertex. Okay, you can also find the vertex without having to do all that just by looking at an equation. Okay, so our first one, okay, is from standard form. Anytime we are using standard form, we're going to use a little equation called x equals -b over 2a. Okay, and that'll give us our x value, and then we plug it back in to find the y value that goes with it. So this is going to be like our input. Okay, so for anything in standard form, we need to know that the equation goes a, b, and c. Okay, so my a value is going to be 3, my b value is going to be -6, and my c value is going to be 7. So we're going to just take all of those and plug them into our equation. So now we'll have x is equal to -b. So instead of a -6, we use the opposite, so it becomes a +6 over 2 times my a value, which is 3. And then I just simplify. So 6 just stays up there. 2 times 3 gives me 6. I'm going to simplify this to 1. So this right here is my x value of my vertex, so 1. Okay, I'm going to take all that and I'm going to plug it back in. Okay, for my x's. So I'll get y is equal to 3. And then instead of x squared, it becomes 1 squared minus 6 times 1 plus 7. And we're just going to simplify. 1 squared gives me 3. Or 1 squared gives me 3. Wow. 1 squared gives me 1 times 3 gives me 3. -6 times 1 gives me -6 plus 7. Simplify that one more step. 3 minus 6 gives me -3 plus 7 gives me 4. So my vertex for this is going to be 1, 4. And if we look at our graph, so I want everybody to pick up their handy dandy calculator and go ahead and type this in, and we're going to draw a sketch to make sure it matches. Okay, so everybody go ahead and type this into your calculator now. All right, so hopefully you all took the time to type that into your calculator. You should have gotten a sketch. Okay, that when we graphed this, we said we had a vertex of 1, 4, And if we look at our picture, it is a vertex of 1, 4, and it should have looked like this. Should have been a really skinny graph going up, okay? And its vertex should have been at 1, 4. All right. So we can do the same thing from vertex form, okay? Since this is vertex form, that means the vertex is actually a lot easier to see, okay? So whenever we're finding from vertex form, we're going to remember that H lies and K tells the truth. Well, what does that mean, actually? Okay, so if I look at this, okay, see we've got vertex form up here. The number in the parentheses, those are H, and the letter on the outsides are K. So if we label this, this is going to be my H and my K. Okay, so we're actually going to do this backwards. Okay, so I want everybody to go to their calculator, type that in, and sketch your graph here. All right, hopefully you took the time to go in and sketch your graph. Okay, if you did so, it should have looked like this. Okay, so it should have looked like this. Okay, so if we look at this, okay, so that's way over here on the left. And if we're finding our vertex from vertex form, we know that H lies and K tells the truth. Okay, well, we're going to look at this H and it's lying. So instead of a positive 6, it's actually a negative 6. And then K tells the truth, so it still gets to stay the same. So my vertex is going to be negative 6, 1, which if we look at our graph, that's really close to negative 6, 1. And if you look at the table, you can also see the negative 6, 1. So if ever it's in vertex form and you're struggling to find your vertex from the table, then you know you can just kind of look at the H and the K. Now, if we look at the axis of symmetry, remember your axis of symmetry is just the x value of the vertex. Okay, so if I look at the two vertexes I found, it would have been x equals 1, and then this one would have been x equals negative 6. All right, so looking at the next one is our a value. Notice that all of our equations up top all start with an a value. Okay, that a value actually tells us a lot of information. Okay, so anytime our a value is positive, so we have a positive number like 2 or 1/2 or just a plain old 1, tells us a lot of different things. The first thing it tells us is which way does it open? Well, anytime our a value is positive, it opens up. So that means my graph is going to look like this. Okay, it's going to open up, my arrows are going up. The second thing that we know is that since it opens up, my vertex is at the very bottom. Since it's at the very bottom, that means it's going to be a minimum. And the last thing we know from the a value is we can kind of find part of the range. Okay, we know that since my graph opens up, notice how the graph is above the vertex. So my range will always be y is greater than or equal to my vertex. Okay, so that's a quick way to remember which way does my sign go. Now, if our a value is negative, so we have a negative 2 or a negative 1/2, it's all going to be the opposite. So now it opens down. Oops. Okay, so it's going to look like this. It's frowny. It's negative, it frowns. So since it opens down, that means our vertex is at the very top. Therefore, we have a max value. And then last but not least, our range. Since the graph is going to be below the vertex, that means my range is going to be y is less than or equal to my vertex. All right, so let's go ahead and look at a few examples. So when we look at example number 1, my a value is just a number up front. So my a value is a positive 2. Okay, it is a positive number, therefore we know all of this information. Okay, so this graph opens up Okay. We also know it has a min value. All because my A is positive. Okay, quick way to check. And then we also know that my range is going to be y is greater than or equal to the vertex. Okay, so we already know all that information, all because my A value is positive. Pretty much the opposite for the next one. Here, my A value is a -5. So since we know our A value is a -5, we know that it's going to open down. Remember, you can find all this information too by putting it in the calculator and looking at the graph. Okay. So since it opens down, we have a max value. And that means that my range is going to be y is less than or equal to the vertex. All right, flip over to the back. Maybe if it'll turn the page for me.